Proton transfers are very common in organic chemistry and they're used all the time, so you need to get comfortable with drawing them. Let's give an example. Suppose we use an alkoxide ion, RO-, and we grab a proton from HCl. This gives us ROH, the alcohol, oxygen has 2 lone pairs, plus Cl-. Chlorine here has 4 lone pairs, whereas here it only has 3 lone pairs. Notice what's happened here. This proton right here has been transferred to this oxygen. Here it is now on the oxygen. In order to show the mechanism of how this proton gets transferred, we need 2 curved arrows. The first comes from one of the lone pairs on this oxygen and to this proton, grabbing the proton. And the second curved arrow comes from these 2 electrons. The tail of the arrow is here, and the head of the arrow is on the chlorine. Whenever you draw a proton transfer, you're always going to need 2 and exactly 2 curved arrows. Students make a couple of mistakes when they try drawing the mechanism of a proton transfer. One very common mistake is to forget to put the second arrow. And students will just show this first curved arrow grabbing the proton, but they don't show that these 2 electrons are going up onto the chlorine. Don't make that mistake. Another mistake that students often make is that the tail and the head of each arrow needs to be in exactly the right location. So, for example, you can't draw this arrow coming like this. Where is this head? Where are these 2 electrons going? Off into outer space? No. They need to come to the chlorine. And the absolute worst mistake of all that students will sometimes make is, rather than drawing 2 curved arrows showing the flow of electron density, sometimes students will draw 1 curved arrow coming from the H and going to here, which is absolutely terrible, because curved arrows do not show where atoms move. Curved arrows show the flow of electrons, and these electrons grab this proton, and then these electrons end up on the chloride. Anytime you draw a proton transfer, there's always going to be 2 curved arrows. Regardless of whether your base is negatively charged or not, regardless of whether your acid is neutral or positively charged. For example, here's an example where our base is going to be neutral, not RO-, we're going to use ROH, and we're going to grab a proton from, let's say, H3O+. We're going to transfer one of these protons on H3O+, let's say this proton here, and we're going to move it over to here. So what we're going to end up with is a protonated alcohol and water. We want to show the curved arrows. We're going to need, once again, 2 curved arrows. One coming from the lone pair and coming to the H, and the second one coming from these 2 electrons, which used to hold this oxygen and hydrogen together. These 2 electrons come onto the oxygen to put a second lone pair on this oxygen here. Once again, 2 curved arrows, the position of the tail and the head. The position of the tail and the head are very important. They need to be exactly right. Let's do just one more example. Here we have a carbanion. That's a carbon with a lone pair. It therefore has a negative charge. And we react that with water. We can have a proton transfer reaction where this proton is transferred over to here, which now just forms an alkane, pentane, and OH-. Now, if we want to draw the mechanism, we have the first curved arrow coming from the lone pair to the H, and the second curved arrow coming from these 2 electrons here and going onto the oxygen. Notice once again, two curved arrows. The position of the tail and the head. The position of the tail and the head are very precise. Anytime you have a proton transfer, there will always be two curved arrows that you need to draw. The following skill building exercises are designed to help you get practice drawing these two curved arrows for any proton transfer.